Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from group 4, section 1 for subject high voltage. So the title of the project is Hvdc dry and wet test. So before I continue my part, I will introduce myself. My name is Muhammad Faris Menuddin, and this is for my group members, which is Muhammad Rashad Rozani bin Azmi, Luna Jason Anak Rahman, and the last one is Muhammad Ali Bazli bin Buhari. So I continue my part, which is introduction. So basically, transmission line is used to support overhead power line. So from the sub transmission and distribution line is to transport power from substitution to electrical customer. So basically, insulator we have three types, which is pin insulator, transmission insulator, and the last one is string insulator. So the insulator is used to support and isolate electrical conduct in electronic component without allowing current to flow through them. So the last one is insulator that carry the weight of a hanging wire while preventing current from flowing through the wire to the ground. So for the problem statement, first is transmission line tower is used transmission insulator as a protection for overhead line from electrical failure of insulator. So second is the problem, which is the failure of the insulator due to flashover that passes through to the body of insulator. The arc discharge between two conductor and earth through air surrounding the insulator due to the flashover, and insulator become useless after puncture. So this figure is show that the flashover. Just example figure. So how to prevent? So in this project, to prevent the puncture under such condition, the thickness of materials is used to be improved. So I go to the objective. So first objective is to design and simulate the overhead line insulator transmission in AutoCAD software. Second is to analyze the performance, high voltage and electric field of the insulator towards the electrical stresses and without environmental impact. The last one is to propose a suitable high voltage laboratory test setup to test the insulator durability to the electrical status. So scope. First scope is we use insulator with option 132 kilovolt. We use glass maximum as we use glass as insulator. Maximum length is 1540 mm. Crimpage clearance 5200 mm and 175 mm area. So the stack and fitting option of cap and pin, all of these will be designed by using AutoCAD software. So the second is the performance of the insulator that has been designed. It will be used finite element analysis, which is FEA in FEMM software. So the last one of the project is this project will focus on HVDC dry and wet test. The prototype will be done and will be tested in detection laboratory, which will have a brief of safety risk assessment and code conduct. So basically, for the laboratory test, we cannot proceed because of COVID-19 pandemic. So we just use FEMM software to simulate the performance. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Bazli bin Bukhari. I will go through for the part methodology. So there are two different diagrams here following to their essential components. The first one is the glass string cap and pin insulator with arcing horn and gut ring diagram. So the essential component there, as you can see in my slide, there are arcing, glass disc, ball socket, and gut. For the second one is about the cross-sectional area of glass insulator cap and pin. There are cap, glass, cement, and pin. For the second part, I will explaining about the flowchart of the process follow finite element analysis FEA simulations. So the first start and determine the type of the insulator, and we create the 2D geometry, define the model next, material properties and boundary conditions, and we go to the mesh model. And the next one go to the decision there, the processing result. If the result follow to the requirement, just go to the record and analysis data. If not, going back, if not result not following to the requirement, go back to the create 2D geometry to define the problem there. That's all. Thank you.
Next, I'm going to present to you about a single glass cap and pin insulator. You might be thinking what is a single glass cap and pin insulator is. Right, cap and pin insulators is a type of porcelain or glass predominate as overhead line suspension or tension sets above high voltage, which is normally 33 kilovolt, and they are also used for substation, bus bar, high level strain connections. Next, due to its type of material, which is glass or porcelain, the line insulators are at risk for surface arcing phenomenon, especially in highly polluted or coastal areas. So this is the performance of the single glass and cap and pin insulator. As you can see, the results from the simulation done, it is shown that a layer of contamination with specified relative permittivity and electric conductivity, as mentioned in the preliminary, has been added to the performance of the glass and cap and pin insulator. Contamination can take the form of variety of things, including rain and chemical pollutants. The mesh for this model is considered as normal. So next, this is the analysis of a single glass cap and pin insulator. So this model was created to evaluate a single insulator cap and pin before it was attached to a group of string insulators. Next, the highest voltage value is 130,260 volt, while the lowest voltage value is 6,690 volt. Hence, the equipotential lines of electric field distribution are narrowed in the region closest to the steel pin for electric field distribution. I think that's all for the single glass cap and pin insulator. Thank you.
My name is Muhammad Rashad Ruzani bin Azmi. So now I will explain about the 12-string glass cap and pin insulator. So as you can see here, this is the 12-string glass cap and pin insulator design with the AutoCAD software. So next, this is the result of electric potential distribution with contamination and without contamination. So there is no significant difference between two insulators when it comes to the contour of potential distribution throughout the string between contaminated and non-contaminated. So next, this is the electric field strength. So the graph shown by comparing the electric field intensity between the distance measured from the HV electrodes. So it can be seen that the contaminated insulator has a slightly greater max voltage than the clean condition. So next, this is the electric field distribution. So if you can see, a polluted insulator electric field is also higher than a clean insulator. So with the contaminated, the blue is the dark blue. So this is the very higher than the clean without contamination. So next, this is the electric field distribution. So the clean insulator has the same electric field strength as a single insulator with narrow equipotential line close to the steel pin. But the contaminated insulator equipotential line of electric field are increased. So this is the summary
of comparison between contaminated and non-contaminated, which is clean condition. So if you can see, the maximum voltage of the contaminated is at 132 kV, and when clean condition, the maximum voltage is 130,580 volt. So net for the maximum and minimum electric field, the contaminated is 370,000 V per M, and for the clean is 432,000 V per M. So that's all for me. Thank you.
Okay, for the conclusion part, we can conclude that the HV testing will be carried out the capability of the glass insulator to withstand overvoltage according to the occurrence of flashover during the dry and wet testing. And last but not least, aside from the avoiding unnecessary additional costs or damaging the equipment, safety risk assessment also need to be done to prevent hazards such as electrocutions or burn to human, as it may lead to the permanent damage or even fatality. That's all. Thank you.